In this video, we are going to take a look at our trigonometric ratios. I want to make sure you are listening to this video, because if you are just writing down what I write down, you will pronounce these wrong, and then it will drive me crazy. So make sure you are listening. So first of all, a trigonometric ratio, or just trig ratio is what we usually say, compares the lengths of two sides of a triangle. The reason this is helpful is that whole similar triangles have proportional sides. So if I compare the lengths of the sides of a small 30, 60, 90 triangle to a big 30, 60, 90 triangle, they will have the same ratio. So that allows us to do a bunch of things as we develop further and further into trigonometry. So for right now, it's just comparing the two sides. Now, we use the Greek letter theta, it looks like this, to represent the measure of an angle. So it's a circle with a line through it. It's the same as a variable. It's the same as an x or a y or a t or a p. It's just a Greek letter variable instead of a, regular letter variable. Now, we're going to need to label our sides, this is important, in relation to theta. So when we use the words adjacent, opposite, that's always in relation to the theta. The hypotenuse is always the hypotenuse, regardless of where theta is. But the opposite and adjacent goes according to theta. So let's do our triangle here. I've got a right triangle because we're doing right triangle trigonometry. This angle here is my theta. That's the one that I am going to relate everything to. Now, across from the right angle is still your hypotenuse. And then we have the word adjacent and the word opposite. So opposite is literally opposite. You're going to go across for the opposite. And then adjacent, you are touching. So this one is opposite, and this one is adjacent. Notice that technically the hypotenuse is also adjacent. It's touching as well, but it's already labeled the hypotenuse. So the adjacent is the leg, not the hypotenuse, the leg of the right triangle that touches the vertex of the angle that you have labeled as theta. Now this is what we're going to use to define our sine, cosine, and tangent. So our sine, cosine, and tangent depend on this triangle here with your measured angle theta. Now, when you write out sine, this is how we say the whole trig function, but when we write it, we're going to say sine. We're going to abbreviate to sin, but we're still going to say sine of theta, and that is going to be opposite over hypotenuse. And then again, the trig ratio cosine, which we're going to abbreviate to COS, but we still say cosine of theta, is going to be adjacent over hypotenuse. And the trig ratio tangent, which we are going to abbreviate to tan, but we still say tangent of theta, is opposite over adjacent. To remember these, you probably learned in the past, so, ka, to, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So, ka, to, that can help you to remember which of these is which. Now we're going to use these, but first let's define our reciprocal functions. So we're going to define those, our reciprocal, ratios. We're not doing functions yet, we're just doing ratios. So this is our three, sine, cosine, and tangent. We're going to use the same triangle. You don't have to rewrite it. I rewrote it here so that we could have it all on the same page. So you don't need to rewrite it because we're using that same opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent, but for our cosecant, our secant, and our cotangent. So now we're going to do those. Our cosecant is defined, this is cosecant, that's the trig ratio. Our cosecant is defined as 1 over sine. So first of all, it's abbreviated as CSC, but we still say cosecant when we write it, of theta is going to be 1 over sine of theta. Now, there is another way to define it. If I do 1 over opposite over hypotenuse, this one's going to end up being hypotenuse over opposite. Now, I always thought cosecant should go with cosine, but it doesn't, so be careful with that. Sine and cosecant are reciprocals. Cosine and secant, which we abbreviate as SEC, but we still say secant of theta. That's going to be 1 over cosine. And again, cosine is cosine is adjacent over hypotenuse. So when I flip that, when I do the reciprocal, that's going to be hypotenuse over adjacent. And then last but not least, this one does make sense. Cotangent is the reciprocal of tangent. We abbreviate it as COT, but we still say cotangent when we write it, of theta, which is 1 over tangent of theta. Tangent is opposite over adjacent, so cotangent is adjacent over opposite. And those are our reciprocal trig ratios. Reciprocal means flip. Okay, now let's use these. We're going to use all 6 because each one could be used for different types of things. So we're going to use all 6. Here's our example 1. We are going to use this triangle, and we are going to find the 6 trig functions for theta. So notice theta is right here. Go ahead and draw your triangle in, and I'm going to label my sides. This one's my hypotenuse. This one is my opposite, and that leaves this one for my adjacent. Remember, the adjacent one shares a vertex and is a leg, not the hypotenuse. Now notice I don't have my hypotenuse, so I do need to take care of that. That's a little good old, if you don't know the Pythagorean triplet that goes with this, that's a good old Pythagorean theorem. Taking the square root of both sides, I get 13. Again, I don't do plus or minus because this is a length, and length is always positive. 5, 12, 13 is one of our Pythagorean triplets. So when I saw that 5, 12, I already knew the hypotenuse was 13, but I wanted to show it to you there. Okay, so this is what I'm going to use to find my 6 trig functions. My sine is going to be opposite over hypotenuse, so 12 over 13. Let me try that again. My cosine is adjacent over hypotenuse, so 5 over 13. And my tangent is opposite over adjacent, so 12 over 5. Now for my cosecant, secant, and cotangent, I can just flip those, which ends up being hypotenuse over opposite. adjacent over opposite. Sorry, adjacent, hypotenuse over adjacent. And then the last one, adjacent over opposite. Pause here if you need to finish those. But really, all we're doing is using the definition. That's all we are doing is using our defined trig ratios. Why is sine equal to opposite over hypotenuse? Because we defined it to be so. It's just a definition. All right. Now, we can use our special right triangles to find the trig ratios of 30, 45, and 60. We're going to do 45 first. So remember my 45, 45, 90. My sides are always some multiple of 1, 1, square root of 2. It might be 2, 2, 2 square roots of 2, or 10, 10, 10 square roots of 2. But when I'm doing the ratios, it doesn't matter. It's always going to reduce down to 1, 1 square root 2. Now, here's the trick. My sign here is going to be 1 over the square root of 2. Opposite, let me actually mark it first. This is the one I'm using. So this is my opposite. This is my adjacent. And this is my hypotenuse. So my sign is going to be 1 over the square root of 2. I hope you see what's wrong with that. So when I do my sign, I'm going to come right here beneath it. You see what's wrong with that? Yuck. I don't like that radical in the denominator, so I need to rationalize it. So I'm going to get square root 2 over square root 4, which is square root 2 over 2. Now notice my cosine also is going to be 1 over the square root of 2, because my adjacent and my opposite are the same. I don't need to re-rationalize, I just did it. And then my tangent will be 1 over 1, which is just 1. Now I only did 3. You're going to do the other 3 in an assignment later, but you will end up doing the exact same thing. Okay, example 3, you are going to do the same thing, and you are going to do it for 30 and for 60. So the reason I went ahead and made a quick copy, when you're doing it for 30, 1 is your opposite, 2 is your hypotenuse, and square root of 3 is your adjacent. When you're doing it for 60, 1 is your adjacent, 2 is still your hypotenuse, and square root of 3 is your opposite. So you're using the same triangle, but you're referencing different angles. So you're going to copy and complete this chart. This must be attempted, and the notes submitted on time for full credit for these video notes. So again, pause here, and you are going to copy and complete this table using your special right triangle for 30, 60, 90.